In geometry, a circle is defined by its center and its radius. While the standard form of a circle equation makes these values obvious, we often encounter equations in a general form that require algebraic manipulation to understand visually. The standard form tells us exactly where the center is and how wide the circle reaches. The general form, however, hides these features. Our goal is to convert the general form into the standard form using a technique called completing the square. We follow a systematic process. First, we organize our terms by variable. Whatever we add to the left side of the equation to complete the square, we must also add to the right side to keep the equation balanced. Let's start our example. We group the x terms together and the y terms together. We also move the constant term, -3, to the right side of the equation, where it becomes a +3. Focusing on the x terms, the coefficient is -4. Half of -4 is -2, and squaring that gives us +4. We add 4 to both sides of our equation to maintain equality. Now for the y terms. The coefficient is 6. Half of 6 is 3, and 3 squared is 9. We add 9 to both sides. Notice how the right side of our equation is growing as we balance these additions. Now we factor. The x group becomes x minus 2 squared, and the y group becomes y plus 3 squared. On the right, 3 plus 4 plus 9 equals 16. We have successfully reached the standard form of the circle. From this form, we extract our data. Remember, the standard form uses subtraction, so x minus 2 means h is 2, and y plus 3 means k is -3. The square root of 16 gives us a radius of 4. Graphing the circle confirms our work. We place the center at 2, -3. Since the radius is 4, the circle extends for units in every direction from that central point, creating a perfect geometric shape on our grid. Sometimes one variable is already a perfect square. In this case, y squared has no linear y term. This means the k-coordinate of our center is simply 0. We only need to complete the square for the x terms. Half of 2 is 1, and 1 squared is 1. Adding 1 to both sides gives us x plus 1 squared plus y squared equals 6. The center is at -1, 0, and the radius is the square root of 6. Watch out for common mistakes. Always balance the equation by adding to both sides. Be careful with signs. X plus 1 results in a negative coordinate. Finally, remember the value on the right is the radius squared, not the radius itself. If the x squared and y squared terms have a coefficient other than 1, divide the entire equation by that number before you begin. Completing the square is much easier when the leading coefficients are simplified to 1. To recap, organize your variables, move the constant, add the square of half the linear coefficients to both sides, factor into binomials, and identify your center and radius. This algebraic tool unlocks the geometry hidden in the equation. Try this one: x squared plus y squared minus 10x plus 4y plus 20 equals 0. By completing the square, you will find a center at 5, -2, and a radius of 3. Thank you for learning with us. Generated by Vision Solve AI.